Anything feeling familiar in this? At least I believe you know about ALU. In the bottom, you know about operand, you know about flag. Fine. And in the left side, bottom, AH, AL, BH, BL, CHCL, DHDL, then SP, BP, SI, DI. Fine. In the top side, on the left, you have ES, CS, SS, DS, and IP. They are the segment registers and instruction pointer. Fine. On the right side of top right, there is a new thing which is called instruction stream byte queue. Instruction stream byte queue. This is the new thing we are having in this particular 8086 architecture. So in order to make you understand, fine, there are few things we need to understand first. Fine. So in this particular diagram, how many sections are we having? Look at this dotted line. This dotted boundary is dividing this particular architecture in two parts. Fine. The two parts are BIU and EU. Alright, BIU stands for bus interface unit and EU stands for execution unit. Okay, so there are two units in the architecture of 8086. Okay, so this particular section is called BIU. You can see written over here this, and this particular section is called EU. Okay, so what we know here, that in total now you have two sections. This particular section belongs to BIU and this particular section belongs to EU. Fine. Now what are the jobs of BU and EU? BIU stands for bus interface unit. BIU stands for bus interface unit. These are the jobs of the bus interface unit. So whatever operation is related with buses, instruction fetching, reading, writing, and calculation of addresses, all these jobs will be done by the BIU. Fetching of instructions, reading, writing, then calculation of this 20-bit address that we did in the last class, where we have the formula of physical address and effective address. Those kind of calculation will also be done by the BIU. Fine. So BIU mostly deals with instruction and mostly it will deal with the address bus. Fine. Next part we have is EU, execution unit. Like it says, execution unit will be doing the decoding and the execution. Fine. I told you the microprocessor works in three steps: fetch, decode, and then execute. Fetch, decode, and then execute. So first part will be done by the BIU. Second and third part will be done by the EU. Fine. But now, before we start with the actual consideration of this 8086, how many of you know about the pipelining? How many of you know about the pipelining? Any idea about pipelining? Anyone? All right, better. Any idea about parallel processing? Parallel processing, so I believe everybody must be knowing. Parallel
One more
processing,
processor together.
definitely. When we are sharing the time and there are more than one task running at the same time, that is called parallel processing. There is nothing typical in this. But along with this, there is one more concept of pipelining. Fine. Anyone have any idea what pipelining? All right, better. So for that, I'll show you the animated form of 8086 operation, how it works in animated view. The same figure I have shown you in this block diagram. I'll show the same figure, and I have already inserted some animation inside. Try to understand few things from that animation. Fine, because there are two basic beautiful concepts hidden in that. What was the concept? Pipelining as well as the process of parallel processing, because where we are standing right now at the 8086 architecture, this is the revolution point in the world of computation. This is the architecture from where parallel processing started. This is the architecture from where the concepts of pipeline came into existence. Fine. So let's see. Let me play this. We can play it as number of times as you want. Just let me know. Are you guys able to see the screen where it is written 8086
Yes.
instruction cycle animated? Is it visible to all of you?
Yes, sir.
All right. Now I'll play the video. Firstly, we will watch it just like you're watching it. Fine. Then we'll discuss it step by step. Fine. Just watch it once. This is the example code we are having. Fine. First code is move BL, comma 06H. 06H is the operand which is getting stored in BL. Fine. Second is move CL, comma 05. So 05 will be copied in CL. Then addition of these two BL and CL 06 and 05 will be added, and the result will be stored somewhere. So this animation is all together about this code. This is all about this code, how this code will be executed. Now look into this first. Are you guys able to say this?
Yes, sir.
Okay. So
So can we watch the video again?
now I'll play it step by step. This was only for just a visual experience that how things runs inside an architecture and how we will be focusing on the pipelining architecture. If somebody is asking you What kind of architecture 8086 is having? Please note it down. The type of architecture 8086 is having is called pipelining architecture. Fine, this is why I wanted to clear, since from the beginning there are two things we are having: pipelining and parallel. Fine. So whenever somebody is asking you, please note these things. These are very critical and they will confuse in the vivas or interviews. Pipelining is a process. Sorry, my mistake. Pipelining is an architecture. Sorry. Pipelining is an architecture. Parallel is a process. Parallel processing. Pipelining is related to architecture. Fine. 8086 is having this pipelining architecture. Now what happens in the pipelining is it supports the parallel processing. Now I'll show you how the parallel processing is getting executed in this 8086 architecture. Right. So see what is happening here. This right now I paused this. So what we have calculated in the last class. In the last class we have used offset address and the segment address, and by combining both of them, now look into this BIU section where this blue dot and pink dot, they started traveling. Fine. That object in which they are traveling, this is called summer or adder. They will be added and they will be calculating the physical address, so that from where the memory they can fetch something. See, the physical address has been calculated since they come out of this adder. The formula that we have discussed, the formula is inside this, and the physical address is generated. Now from memory, it is connected. Fine, and from that it fetched 2 byte of memory because 16-bit data, 2 byte. Now it is in the bus. Now that bus is getting it back to the portion. That particular portion is called queue. Right? 6 byte long queue. All right. So what is happening here? See, this is the part what you need to understand. Whenever the microprocessor 8086 executes an instruction and it starts from the top, fetching, decoding, and execution starts from the top, the first instruction enters the queue first. जो पहला इंस्ट्रक्शन है वो सबसे पहले क्यू के थ्रू पास होगा. Fine. Likewise, the other instructions. Fine. Now see what next. After storing the first byte in queue, now the next location, next generation of address, again this blue dot and pink dot are getting generated and the address has been generated. Now look what is happening. This is the beauty of this animation. Now look at this. There are two things happening at the same time. Just have a look at this. Let me put it back. Yes, it reaches the queue. Just keep watching, keep watching. It's stored. Now see, there are two things that will be happening at the same time. Address will start from the BIU and this byte from Q06H will start moving. Just look at this. It started moving on the right side, and on the left side inside the BIU, the address is getting generated. Fine. What are you watching here? A blue dot, sorry, a red dot and a black dot. They both are in motion. A blue dot, sorry, green dot now and a black dot. They both are in motion. Again, this black dot showing the movement of 06H from inside the queue to outside in the data bus, and where it is destined, it was destined to some register. It is destined to some register, so it will be loaded into the register organization of this place. So where it was destined, the destination of this 06 was BL. Fine. So data which has been operand which was picked from memory interface it is then loaded into the specific destination, whatever the destination it was having. Now look, next instruction, move CL, and the operand here is 05. 05 has to be loaded into the CL. Fine. Now this is in the queue. Now see what is going to happen. The data is getting loaded from queue to databus to register. At the same time, next byte from the memory is getting loaded into the bus. Again, it's been loaded into the queue. So what you notice over here? What you guys are noticing here? Tell me. Next part was next instruction where we are adding two numbers which are stored in BL and CL, and they'll pass through ALU. ALU will add them and they will be loaded back to the result will be loaded back to the accumulator. Fine. So let me play it again. So what you guys noticing in this? Where is the pipeline? Where is the pipe? Where is the pipe? Can anyone tell me where is the pipe in this architecture? Anyone? This is your pipe. Your 6 byte instruction queue 1, 2, 3, 4, 5, 6. It is on the top right side. This particular place is called a pipelining architecture. It amplifies it into the pipelining architecture, because look at this. This is acting like a pipe which can store how many bytes? It can store 6 bytes. So this particular thing is called 6 byte instruction queue. 6 byte instruction queue. So that is the beginning of your pipelining architecture. Now see the beauty of this pipelining. What it is doing. It has given us a base. See what is happening here. There are two things which are happening at the same time. See, there are two balls of two different colors showing two processes. Right now, green and black. Two processes are happening at the same time. Now observe, this is the advent of the parallel processing. By using a pipelining architecture, which is your queue, it supports the parallel processing, so that two processes can be executing, or two things can be executing at the same time. Fine. So how it is helping us? Tell me how it is helping us. How pipelining thing is helping us? कोई बताएगा मुझे? How it is beneficial? Quick.
So while the first instruction is moving, it stores the other value.
Definitely, we are saving the time. How we are saving the time? We have only three steps: fetch, decode, and then execute. All right. Till the time, now look at it again. First byte will be fetched, and it will be loaded inside the queue topmost location. Fine. The moment. Now look at the moment. This is actually the parallel processing. The moment second byte is getting loaded from the memory, fine. The previous byte has been shifted from the queue and it has been loaded in the data bus. Fine. Otherwise, it could have been what? It could have been a sequential process. पहले fetch होता, फिर decode होता, और फिर क्या होता? Execute होता. Fine. But what is happening here? Fetching and decoding. This is happening at the same time. Fine, so we have saved a lot of time by creating a parallel process by using only single pipe. What is our pipe? The pipe is your queue. Fine, by using only a single queue of 6 byte, we created a parallel processing for fetch and decode. They are happening at the same time. Fine, एक ही टाइम में हमने दोनों काम करा लिए. See, this is what is the advent of parallel processing. A small beautiful concept. All right. So now look at this whole structure. Isn't it a very simple one? More simple, I know. It's just a single pipe having only 6 bytes. All right. And this is the beginning of the concept development of the pipelining process. Then from pipelining, we are able to have the parallel processing. Now just imagine the number of pipes. If I increase the number of pipes or queues in an architecture, what can happen to the parallel processing stages? Just imagine I'm having 100 queues like this. Fine. And if my processor is capable to handle all of that, now look at the speed of the processing. How many parallel processing can be done at the same time? Are you imagining it right now? If just imagine there are hundreds of queues like this and they are doing parallelly 100 things, and my processor is actually capable of doing that. It can process a million instructions in a second. Fine. Now just imagine the speed, the concept they have developed. If the concept could have been amplified in a proper manner, how powerful it could be. Fine. So do you remember the time when suddenly after Pentium 1 and 2, suddenly something happened in the graphics, and suddenly you are having this windows and floating wallpapers, and you are searching something or your internet, and something is running in the background. There are many processes running at the same time. How that thing was possible? Earlier, it was only sequential. They were supposed to do only one thing at a time, and that's it. There were no parallel things running even in the background in the computer. There are many jobs running in the background. So how these things could have been possible? They were only possible by implementing those pipelining architecture queues. Those who can handle the instructions from different routing, different paths, and they can be executed according to their priority or requirement. Are you getting my point?
Yes, sir.
All right. Now just guess. Just make a wild guess. How many queues could have been in Pentium?
Around 100 or 500.
All right. All right. Anyone else? Just make a guess. Anyone? Initially, it started from yes hundreds. Then from hundreds, there is thousands. Then after exceeding from thousands, they started implementing a new kind of design. Fine. So it's not always good to work on a single aspect which enhances the performance. They've also parallelly started researching in every part. So after that, you will notice there were many changes. Even they have multiple ALUs in an architecture in Pentium. Pentium is even having multiple ALUs. They were even designed to operate data in a multiple entry order also. So the simple concept landed us into the various stages of development. Fine. Then another aspect was how to speed up the BIU, because there are things, if the data is not getting fetched at a faster rate, it will not be processed. So we also have to increase the speed of BIU, because it is dealing with the external aspect, which is memory. Memory is always external in processor. So everything is not like only they focused on the pipelining, they focused on every aspect to improve the performance of the system. Fine. So this was my attempt to make you understand the architecture of 8086 in a better way by the animation. I hope that must have helped all of you. Was that good to understand that animation
Yes,
view?
sir.
Because I could have
Yes.
not shown you without animation. This picture, I may not be able to make you understand that this is going from this is going from this. Animation could be a better approach. Okay, so is that clear, all of you?
Yes, sir.
Architecture.
Yes, sir.
Okay. Still, there is one thing I'm leaving intentionally. I'm leaving from very beginning. Okay, this is what I want all of you to work upon. This thing is important, I know, but I'm leaving it intentionally so that you guys can search more about it. There is one thing I have intentionally left in this particular diagram. Tell me what it is. I have covered almost everything inside this except one. Are you guys watching IP inside? IP just next to DS.
Yes, sir.
IP stands for instruction pointer. IP stands for instruction pointer. I want all of you to look for it. What is the function of IP? Instruction pointer. It must be giving you a hint that it may be related to pointing to an instruction, but it's not only that. It's not only that. Alright, so let's move to the next. I have some questions ready for you since from the last class, and they are the questions from your competitive examinations, like we have done in the last class. Yes, now look at this first question. If the data segment location starts from 1000H and a data reference contains the address 29H, where is the actual data? कोई आंसर बताएगा? If a data segment starts at a location 1000 and the data reference contains the address 29H, where is the actual data? Okay, look at the solution we have. So what data reference given to you is actually the offset you are having. Fine. 29H is not like that. It is 0029. Alright. So if you open it up in the binary form, you will get something like this 0029. So once you know about this offset and you already know the segment base address, you know the formula segment base address 1000 multiplied by 10H plus 0029. The answer will come out to be 10029. Is that clear? Is that clear?
So please repeat the
Yes, sir.
It is just one or another way of writing it because they want to confuse you. That's it. Okay, then now come to the next question. Logical address is specified as, there is another way of writing it, a segment colon offset. This is also written like that. Segment पहले लिखा होगा, colon then offset address. Fine. So if physical address is to be obtained by shifting the segment address, fine. So what is needed here? Now look at the last line, A4FB colon 4872. If nomination is written like this, it is written in that manner, it means A4FB is the A4FB is the starting of the segment, and 4872 is what? This is your offset. So you know the formula, A4FB multiplied by 10, it will become A4FB0, and 4872 will be added simply A9822. So just remember, this is also one way of writing it. You can also get a question like this. Once you know the answer. Once you do not know, it will not be. It will be very tough. You will not be knowing this. And these questions actually troubles you in the like gate examination or placement examinations. Is that clear?
Yes, sir.
Now look at next. This is the schematic showing you how these things are getting calculated. What happens when we do that. So DS is your data segment and it is starting from 7FA2. 7FA2. And the offset value is 438E. So in order to calculate, you know formula, segment base address multiplied by 10, it will become 7FA20 plus 438E, that will be 83DAE. You can see this is 83DAE physical, and the segment starts from this. Fine. Now after calculating this, they may ask you what is the upper range and what is the lower range of the segment. Fine. So once we know the starting location, the lower range will always start by adding 0000 to the physical address. So first calculate the physical address 7FA20, then add 4 zeros. Simply there's nothing to add. That means this will be the lowest or the lowest memory location or the lower range of the segment or the address. After that, what will be the upper range? For upper range, we need to add the 64K. That means 4 Fs. The biggest number of 16 bit, 4F. 4F means FFFF. This will give you the upper range. That means the last address of the 64K segment. So this is how you can calculate the upper range also. Fine. And if they ask you how to write in the logical format, the logical format is the colon format. 7FA2 colon 438E. If they have to be written in a logical format, they will be written like 7FA2 colon 438E. Is that clear?
Yes, sir.
Is that clear, all of you?
Yes, sir.
Yes, sir.
All right. So these are the kind of questions you will be having. Okay. So now tell me what will be the answer for this one. Quick. What linear address corresponds to segment oblique offset address 0 to 8F colon 0030? What linear address
02920.
corresponds to? I'm asking corresponds to. Anyone? Quick. There's nothing to calculate. You know the formula. Physical address plus colon offset, the answer will come out 02920. That's it, nothing. Next question, what segment addresses corresponds to the linear address 28F30? Try to understand the question. What segment addresses corresponds to the linear address 28F30H? Anyone with the answer? See the answer.
Sir, how this is divided in the ratios like that?
Sorry?
Yeah, then 28F0,
Yeah.
then 0030. How it's divided?
It's not divided. I'm just asking. You have a linear address. Linear address means the physical address.
Segment
Fine.
and ratio.
Now listen to me first. How this 28F, how many ways or how many addresses are there which can corresponds to landing us, giving us the same physical address? Now come to the first example. 28F0, this is the segment address, colon 0030. So if I create physical address from this, I'll be getting the same value. Because 28F0 multiplied by 10, it will become 28F00 plus 0030. What it will give me? 28F30. Next, 28F3 colon 0000. This will definitely give me 28F30. Then next 28B0 colon 0430. My point is, you need to understand that question can come in any way. The question can come in any way. Just be careful what they are looking for. All right. So this is, now you guys know about it. There's nothing left. Flags we have already covered in detail. So only one thing left with this particular topic is called addressing modes, that we'll cover in the next class. All right, that is good from my side. So in today's class, anything anyone wants to ask, any doubt, quick, regarding architecture or
Sir, how we
pipelining?
calculated those addresses? Or we just gave the reference in from the
They
upper
will
end?
mostly what happens is they give you in options A, B, C, D. They generally comes in the MCQs. Fine. Or if you seriously want to calculate, there is a trick. I'll tell you in the tutorial class. Fine. Because there is no limit to it. That
Okay, sir.
particular linear address can be calculated in a number of ways. Fine. So we need to focus only on getting the answer. So there are tricks to start from finding the answer, so that we can eliminate which one is wrong.
Okay, sir.
Okay.